Hello, we are Waste Coast Solutions, a consulting company that are stewards in residential recycling projects. As a team, we foster the triple bottom line in all of our projects, acknowledging the importance of people, planet, and profits of a community. Now today, the team consists of Frida, Victor, and myself, Sarah. Before we start, the team would like to acknowledge that the project was worked on the traditional, ancestral, and unceded territory of the Musqueam people. Now, summary of today's agenda starts with the introduction of the project, then an overview of the proposed solutions with evaluating its feasibilities, and then finally, we will then conclude with our recommendations. So, now plastics. This is a very relevant topic in today's global environment and economy. In 2022, an estimate of 400 million tons of plastic waste was generated globally, and only 9% was recycled. This is a major problem as the current industry follows a linear model of a resource consumption that endorses a take, make, dispose pattern. Unfortunately, this reflects SWANA's notorious plastic waste stream. According to a recent audit from 3 waste management facilities, 19% of plastics make up SWANA's stream. And the average inbound contamination rate of recyclables is 28%. These issues then complicate recycling efforts, operational challenges, and financial burdens on the local waste management systems. Let's take a look at SWANA's geography.
So SWANA is made up of 3 major metropolitan areas, all surrounded by rural communities as shown here. Due to the natural coastline along the east, Majora Beach is an attractive tourist destination, and most incoming tourists come through the Majora Beach International Airport. The waste here is currently managed at their landfill. Now Bumpa is located at the center of the state with a waste-to-energy facility. The general demographic here consists of retired elders that are cautious of their health. Lastly is Daunton, and this city is holding majority of young families that are cautious of their expenditures. It is also important to notice that SWANA has a similar climate to British Columbia. SWANA is situated by the Ring of Fire with several volcanic regions conducive to geothermal energy. A notable region is between Bumpa and Majora.
Now that we have a good understanding of the state, let's further look into the data collected from the state's audit. The most critical variables influencing SWANA's waste composition are the following: contamination rate, waste management types, demographic, and finally, the municipality concerns. From this graph, we see that plastic is the 4th major commodity, with the other groups consisting of paper, C&D, and organics. A summary of the analysis is found in this chart. We find that the highest contamination rate lies within Majora Beach at 37%. The lowest rates are found in rural regions at 8.9%. All the major cities have a single stream curbside system, whereas rural areas rely on recycling drop-off points. Both Majora and Daunton currently have landfills located 10 miles from the city. And Daunton can hold for another 34 years, whereas Majora has a capacity of only 12. Bumpa holds a waste-to-energy facility that will close in 20 years. Now, when closely evaluating Majora's data, we found that there are inconsistent relations between the participation rate and contamination rate. This graph shows 2 trends. We see that Majora has a high recycling participation rate and also a high industrial waste composition. From this evaluation, there is likely a chance that the high contamination from Majora comes from improper disposal of waste by tourists. Another important factor to note is the waste distribution at the 3 waste management facilities. Here, the distribution is shown. We find that Majora and Bumpa are mostly composed of their own municipal waste, whereas Daunton takes in 2 other streams, and their own municipality holding 20%. From this evaluation, the most notable concern that influences SWANA's plastic waste contribution comes from Majora and Bumpa. If the contamination rates are lowered, Bumpa's reliance on Daunton's landfill could be reduced and recyclable materials can be used in a circular economy.
Onto the design basis, the main objectives we set are to reduce plastic waste by 40% and contamination to 15%, to increase participation and awareness of residents and tourists, to have a facility that consumes minimal energy, reducing our impact on climate change, and that the facility is resilient to regulatory compliance, meaning it's able to withstand future changes in regulations and greenhouse gas reduction goals. To increase industry responsibility through policies and integrate education about waste management in school curriculums. The most significant constraints include that we must stay within the 8 million budget during the 10-year timeframe, that the technology we choose is feasible to the budget and the population of SWANA, and that it takes into consideration the remaining capacity of existing infrastructure. The assumptions we made throughout the project include that SWANA has a population growth directly proportional to its waste generation, governments and corporations are able to communicate and cooperate in sharing information and combining efforts for waste reduction, citizens are open and reasonably willing to adhere to regulatory and educational changes, the climate and geography in SWANA is similar to British Columbia, Canada, the rate of recovery at the existing recycling facility in SWANA is 80%, and currently these recovered materials are sent overseas for processing.
So moving on to our proposed solutions, we'll be starting with our community engagement portion of the project. This component of the solution aims to focus on a theme of prevention over treatment through educating the public and promoting better awareness. Furthermore, the team has also updated some bin designs, which we will dive into later. With the community engagement plan, the team is hoping to increase recycling participation rates across all of SWANA across all demographics. So this will also be more of a low to moderate cost process with a large impact, as less contamination will reduce the strain on the technological aspects of the project. Our team plans to develop an ambassador program similar to the large volunteering organizations that would provide mentorship. With the ambassador program, organizers at the top managing university volunteers, then down towards the bottom with high schoolers and elementary students in the program that would gain benefits such as volunteer hours, mentorship, and experience. As educating a younger audience is important, the ambassador program would also create teams that perform skits and other educational content for elementary schools. Onto the topic of schools, our team is planning to implement curriculum upgrades, specifically adding in content to teach elementary schoolers to high schoolers, such as basic recycling and waste management, along with material sciences and its impact on our health. So topics such as understanding how plastics and how things such as microplastics can be of concern, and additionally, small field trips will be useful for the students to understand operations of waste facilities, especially as a day-to-day person, we usually don't think about what happens to our waste after disposal. Furthermore, social medias such as Instagram, TikTok, and the news networks will be used to occasionally interview waste management operators and gather clips of processes involved to further educate the public. This slide is a demonstration of what students can learn, and such as the impact of microplastics and other health-related concerns over poorly managed waste. This will help create a more personal sense of responsibility where my waste management is directly proportional to my health. So lastly, looking at an updated bin design. So we looked back onto the anti-smoking campaigns where the cigarette packages had infographics on the dangers of smoking to discourage people from smoking. This is a very similar concept. So the new designs for the bins would have a top visual layer where people can understand what is recyclable or not, and number two, have an image such as the turtle here, which makes people think more deeply about their impact when they throw their waste out. These bins would be replacing many of the current bins around the state as a way to subconsciously improve contamination rates and increase awareness of the importance of better waste management.
Our main guide in implementing policies was the extended producer responsibility approach. This framework encourages circular economy in the industry as it requires that the design process considers the end of life of its products or services with a simpler and clearer recyclable materials. Recycling becomes more intuitive for the consumer, increasing recycling rates and reducing waste in landfills and government management costs. Lastly, it gives industries the responsibility to develop their own recycling programs. At SWANA, this policy will require mandatory monitoring and reporting of waste and diversion rates, which will give industries a better idea of their current situation and how they can improve. It will also encourage collaboration to implement recycled materials in their production and invest in research and innovation in materials that are better for the environment. We also propose to implement a plastic bag tax of 10 cents, where 20% of the revenue goes back to businesses to enforce this tax and incentivize them to make more changes. Other single-use items we examined are straws and condiment bags, but due to accessibility, we recommend that they be provided upon request. A small roadmap for the plastic bag tax is to continuously monitor consumer behavior and trends, and if there is a decrease in tax revenue after the first year, SWANA may continue with this approach. Otherwise, it is recommended to enforce a ban. Throughout the world, the first year has shown a decrease of up to 30%, and coupled with community programs, we're confident that this can be achieved. In addition to the plastic bag tax, we also propose giving a fine during waste pickup if recyclables are contaminated, and having fees and incentives in the residential property tax based on contamination rates. So as shown in the table, if the contamination rate is below 10%, the property tax is decreased by 2.5%. If it's between 11 and 19%, there is no change, but if it's above 20%, the property tax increases by 5%. Now, to increase tourist awareness, a video will be shown on airplanes after the safety briefing and upon arrival, and educational videos will be available for in-flight entertainment. Lastly, we want to make data available by publishing open data and sharing annual status reports. This will greatly help make decisions moving forward and serve as guidance for neighboring states.
As the main objective to reduce SWANA's overall plastic waste generation, the inbound waste management was previously addressed through social intervention. However, to actually achieve this goal of recyclable plastics, two main objectives would be needed to address through technology implementation. The first being the outbound contamination of plastics from materials recovery facilities must be less than 10%. Secondly, there must be available technology to process diverted plastics. The 10% was previously mentioned was based on ISRI standards and from evaluating several feasibility studies. Before proposing technology, the plastic waste generated was analyzed for characterization. Here, this graph demonstrates the highest plastic commodity is flexible plastics at 40%. Following that is PET and HDPE bottles. The recyclability of these plastics were then further analyzed, with PET and HDPE having the highest potential. Technology solutions proposed in this section follow the following constraints: adherence to plastic resin types, ease of operation, and finally, financial feasibility. The proposed technology plan will have two options as shown here. To deal with the high inbound contamination rates, the first proposed solution is upgrading MRFs at Bumpa and Majora. The facilities are shown here currently operate as a single stream. Automation of MRFs have gained attraction with improvements in optical sensors. The most common type is near-infrared or NIR sorters. These sorters use a non-destructive yet rapid process to analyze and sort post-consumer products such as PET, HDPE, PP, and PS. These sensors detect variations in absorption, transmissions, and light scattering in infrared wavelengths. A current issue that most MRFs face is the problem with flexible plastics plugging screens. This can occur up to 5 times a day, lasting 30 minutes. However, there has been a study on the strategic placement of NIR sensors near fiber streams to reduce the contamination rates before entering the screen sections. Therefore, this schematic shows the potential upgrades. And this is how the upgrades will influence the facilities management. Currently, there is no plastic recycling facility in SWANA. This second solution adheres to this problem. There are generally 3 major practices of plastic recycling, consisting of mechanical, chemical, and thermal. These 3 then fall under 4 categories as shown here. The different practices have their merits and downfalls. Therefore, a thorough analysis of each technology was analyzed through a cost-benefit analysis. Here's an unweighted matrix which shows mechanical recycling having the highest score. However, to align with the project's objectives, more leverage was given to financial feasibility, environmental soundness, and energy efficiency. Here, the outcome gave the highest score to geothermal mechanical recycling systems. Due to the high geothermal activity in the region, the direct utilization of geothermal steam for these reservoirs can be utilized. Currently, the site between Bumpa and Majora holds a well with an average temperature of 260 degrees Celsius. Here's a list of plastics with the respective softening and melt ranges. We see that PET can potentially be recovered. But how does this actually work? Well, the process starts by shredding the plastics into smaller pieces. The pieces are then cleaned in a tumbler using steam and hot water. The second cleaning stage of plastics are placed in sediment tanks where sand is separated. Water is then pressed from plastics using a screw press, and plastics are further shredded while simultaneously being dried using two-stage drying methods. The third drying stage is applied using hot air from geothermal steam for the plastics to then be pelletized by melting and extruding it into molds. A highly documented example of this is the process from Iceland, where they currently operate an annual 5,000 tons and plan to scale up to 20,000 tons. However, in order to adhere to the $8 million budget, only one of the two options proposed can be implemented. Here, I have summarized the plan. If contamination rates are stagnant or increase, then proposal 1 should take action of including an automated MRF. Option 1 includes 3 optical sorters dealing with PET, HDPE, and LDPE film at Bumpa and Majora's MRFs, and the recovery efficiency would increase to up to 90 to 97%. However, if the inbound contamination rates decrease, we can assume that the current manual MRFs can produce lower outbound contamination rates, and the second option of geothermal recycling facilities should be constructed. Option 2 accommodates SWANA's novice level of plastic recycling and will only take 20% of Majora's PET plastics. All resin will then be distributed locally by assuring companies of the high quality resin for utilization in products such as pipes, bottles, and clothing. Remaining waste will then be sent to Bumpa's W2E and be recovered for energy.
So moving on to our financial assessment. The financial analysis breakdown of the proposed waste management initiatives are split into 3 main categories. Number 1, community engagement, policy and regulation, and lastly, technology. This cost breakdown covers all the relevant costs over the 10 years of the project's lifetime, including and accounting for a 3% annual inflation rate, minus all the operational costs. Next is our net revenues over the duration of the project. This graph shows that the net revenues of the auto sorting option and the geothermal option. This graph also shows that the project is always within budget and even generates profits over time. In this next graph, this is a breakdown of the costs between all the different components individually, and you can notice the difference between the technology options and their financials. Furthermore, the community engagement portion is net negative, but this portion will indirectly affect the technology operational cost as the portion with lower contamination rates.
During the risk assessment, we identified that fluctuating markets will affect staying within budget, changes in regulations will have impacts on the budget and timeline, acceptance from the community and stakeholders is not guaranteed, and the solutions we implement may have unforeseen environmental impacts. However, the mitigation strategies we took are to have contingency within our budget, aim for industry collaboration in projects such as working with airlines for the video, and for industry to also invest in innovation, for regulatory changes to follow the best available practices, in community engagement to make data public and accessible, invest in education of the younger generation, and form long-lasting communities. Lastly, the best available and feasible technology must be used to minimize environmental impacts. In assessing the sustainability of the project, we examined how the technology proposed has an impact on the environment compared to business as usual. It was found that for the proposed solution, the recycled pellets have a 40% less global warming potential than virgin PET, and transportation from the city to the proposed location emits approximately 200 tons of CO2 equivalent. However, it is safe to assume that this results in less emissions compared to shipping outside of the state. When comparing mechanical recycling to other available technologies in energy recovery, chemical recycling, and physical recycling, the proposed mechanical recycling of PET has the most net greenhouse gas savings as shown at the bottom of the graph. The Sustainable Development Goals or project needs are number 4, quality education, as we are enforcing ways of taking care of the environment when implementing waste management in curriculums. Number 9, we are encouraging investment in the innovation of industries and infrastructure. 11, we are making cities in SWANA more sustainable. And 12, encouraging responsible consumption and production through policies. Lastly, through all of this, we are taking action in partnership with industries and communities to minimize our impact on climate change and improve aquatic and land ecosystems. The timeline shows a summary of our milestones. The first year mainly consists of planning and research. The second and third year, testing begins. The third year is the busiest as the automated sorting facility begins operation. It is also the launch of the Ambassador Program and updated curriculum, and the first round of community grants and bin design events. The second rounds are in 2032. In 2028, the tourist video is implemented in airplanes, and it is the first round of innovation and research grants, with the second one in 2033. Lastly, if the second technology is implemented utilizing the revenue, the geothermal mechanical facility begins operation in 2030.
Now, to conclude, the comprehensive waste management strategy for SWANA balances regulatory measures, community engagement, and sustainable development goals to achieve resiliency and sustainable plastic waste management. Now, moving forward, we hope to allocate the revenue generated on upgrading the geothermal recycling facility to hold a greater capacity, and then plans to upgrade Bumpa MRFs into an integrated waste management facility. This would include synergies between waste, water, and energy. We would now like to acknowledge the team at SWANA and our advisors. And we are Waste Coast Solutions. We will now open the floor to any further discussions and questions. Thank you for listening.